Okay. So this is what we have here. Let's do some now. We know what a square root is, and one thing that's good to look at then, one thing that mathematicians do is they'll consider its properties. You know, if they find something new, they want to analyze it. Okay, so let's look at its properties. The square root of 225, well, that's equal to 15. Okay. Now why is that? Well, 15 squared is 225. And also, since 15 is non-negative, so 15 squared is 225, and 15 is non-negative. Okay. So that's what we get here. Now the square root of 15 squared is 15. And now why is this? Where did this come from? Well, notice though that we have 15 squared is 225. So all I'm doing is I'm taking this and putting it back. I'm using these two. 225 is 15 squared. I substitute, I get the square root of 15 squared is 15. So I'm just, in a sense, combining these two equalities. Over here, same idea. We know the square root of 36 is equal to the square root of 6 squared, because 36 is 6 squared, and that's equal to 6, as we saw before. So it's really the same idea. What am I getting at here? This is what I'm trying to get at. If you take a number that's non-negative and you square it, and then you take its square root, you get the number back that you started with. That's what I'm saying. Okay, so again, you take a number that's greater than or equal to 0, non-negative, square it, then take the square root, you get the number itself back. So it's almost like squaring and square roots are like opposites in a sense. One will undo the other. That's what this is saying. No, excuse me, hold on. Taking the square root will undo squaring. That's what I should have said. So again, if I misspoke, so I'm sorry about that. So, but that's what this is saying though. Okay. All right. So that's one property. Well, got ahead of myself. Here's another one that's really nice. Namely, here, if you take A to be a non-negative number and B to be a non-negative number as well, the square root of the product equals the product of the square roots. The square root of a product is the product of the square roots. So that's what we have here. So in other words, taking the square root is compatible with multiplication and division. You just need the denominator to be not 0. So the B here has to be strictly positive. All right. Now, this is not a proof, but we're going to illustrate this. The square root of 25 times the square root of 16, like so. This is equal to 5. Well, the square root of 25 we know is 5. Square root of 16 we know is 4. So this product is equal to 5 times 4, which is 20. Now let's look at it. Now let's look at this though. The square root of 25 times 16. Well, 25 times 16 is 400. So the square root of this product is the square root of 400, which does turn out to be 20. Okay, so this is equal to 20, this is equal to 20, so they're both equal to each other. That's just illustrating this property. It's not a proof, It's illustrating it though. So that's what we get. All right. Now, next what I want to go into is, so that's really square roots, like what they are. We're not done yet though, because I want to do simplifying square roots. So that's what I want to do next, how to simplify them. All right. Okay, well, first, before we actually simplify them, let's look at perfect squares. Okay? That's what we're going to look at first. Perfect squares. Those by definition are just numbers of the form m squared, where m is a positive integer. You know, a natural number, that is, which in this class is a positive integer. So perfect squares are numbers of the form m squared, where m is a positive integer, such as 1 squared, which is 1, 2 squared, which is 4. So 1 and 4 are perfect squares. 3 squared, which is 9. That's a perfect square. 4 squared is 16, and so on. Notice 0 is not a perfect square, because again, 0 is not a natural number. So 0 squared is not in this list. Didn't make the list. All right. So we have to use these now when it comes to simplifying square roots. But first we have to say, well, what does it mean for a square root to be simplified? It means the radicand has no factors that are perfect squares except 1. Remember, the radicand is what you're taking the square root of. So the only factor from this list of perfect squares is 1 if it's simplified. Okay, that's awesome. Well, let's do some examples then. So again, to be simplified, the radicand, what you're taking the square root of, can only have 1. For it to be simplified, it has to have no factors that are perfect squares except 1. 1 is going to be a factor of every number, so you can't get around that. Okay, square root of 15, right? Well, is this simplified? Well, let's look at the factors of 15. The factors of 15 we know are 1, 3, 5, and 15. Going back to our list, 1 is a perfect square, 3 is not on the list, 5 is not on the list, neither is 15. So that tells us the square root of 15 is indeed simplified. Okay, that was fun. What about the square root of 20? Well, if we look at the factors of 20, we have 1, 2, 4, 5, and there's other factors. But notice that 4 on the list is enough because 4 is a perfect square. You know, 4 is 2 squared. So 4 is a perfect square. Again, the numbers in the bottom row, those are perfect squares. The corresponding m, so to say, is above it. So this is not simplified. What about square root of 45? Well, we could list all the factors, but it's really enough to see that 9 is a factor of 45 because 9 is a perfect square. 9 is 3 squared. So that's what we got here. So that's what 9 is. Okay. Okay, so that's not simplified. Well, if we have something that's not simplified, it's natural to ask, how do we simplify it? Well, that's where this procedure comes into play. So to simplify a square root, what you're going to do is you're going to find a perfect square besides one that is a factor of the radicand. A perfect square that is one, besides one, excuse me, that is a factor of the radicand. I mean, there's going to be one if it's not simplified. If there is no such perfect square, then it is simplified. You're going to factor out that perfect square, okay? Then you're going to use this property. The square root of a product is the product of the square roots. And what's going to happen is you're going to take out the perfect square, and you're going to repeat this if necessary on the remaining root, on the remaining radical, that is, square root, that is. Okay? So you may have to do this process more than once. That can happen. I know in the book what they actually say is to find the largest perfect square that is a factor. That might make it a little bit easier, but you don't have to do that.